Our video today is going to talk about PCR, but more specifically, PCR primers. There are plenty of videos that can talk to you about PCR. That is the amplification of a region of DNA into thousands, hundreds, millions of copies. But today we're going to focus on the primers we use to build this PCR product. So let's start by talking about DNA. You recall that DNA is double-stranded, so I'm going to draw two strands of DNA right here. And what I want to point out to you is that DNA has an orientation. The top strand of DNA is usually written in the 5' to 3' direction, and we read it left to right like you would read a book in English. But then the second strand of DNA here is anti-parallel. That is, the 5' end of the top strand matches up with the 3' end of the complementary strand. Now, in order to talk about PCR, we have to talk about primers that are used to target the region for amplification. We could also say that they flank the region for amplification by PCR. So let's draw some primers down here. Primers are typically single-stranded, so let's draw from 5' to 3', and the 3' end is where the DNA will be added on as we're extending during the PCR. Now, of course, if we're going to be building this new strand of DNA, we need to have a template to read from. And we know from above that this template will be anti-parallel to the primer. So we're going to read the template in the 3' to 5' direction here. And we're going to build the new strand of DNA in the 5' to 3' direction here. So let's try some PCR on these top strands. The first thing I'm going to do is denature the strands of DNA using heat. So I will heat them up to about 95 degrees Celsius and split the strands in two. As we lower the temperature down, maybe to 55 degrees, the primers will come in and bind to these sequences of DNA. And would you look at that? We've got a template sequence right here that starts with a 3'. As we said below, the 3' to 5' is what we're going to read, and then I'll put our primer in 5' to 3'. Okay, now this primer will extend in this direction with the help of Taq polymerase. Let's think about what the sequence of that primer would be. Now, often you'll just be given this top strand of DNA information. So let's write the sequence on the top strand. This sequence is A, T, G, G. What would be the complementary sequence on this bottom strand of DNA? Well, it's going to be T, A, C, C. So then we can also know the sequence of the primer. The primer sequence is going to be complementary to the bottom strand, A, T, G, G. One of our primers is going to have the same sequence as the top strand of DNA. Now, let's think about the second primer that we're going to need for PCR. With this first primer here, note that it's pointing into the gene that we want to amplify. So if I put another 5' to 3' primer here, maybe I could put it right here, 5' to 3', because look, it has to be anti-parallel. Well, now this primer will be reading out away from the gene we're interested in. So that's not going to work. Let's put our second primer at the far end of the region we're interested in, way over here. And because it needs to be anti-parallel, we're going to read this template in the 3 to 5 direction. We're going to build our new primer, or build our new DNA sequence in the 5 to 3 direction. Okay. let's think again about the sequence of this primer. Since we're often given this top strand DNA sequence information, I'll tell you what the top strand is. It's CTAA. Well, what would the sequence of the bottom strand be? Well, I know we don't care about the bottom strand right now, but bear with me. The bottom strand is going to be complementary, GATT, and that will be the sequence of the primer as well. The primer will be complementary to the top strand, GATT. That means in order to find the sequence of this primer, we first need to take the complement, that is the complementary sequence to what's given on the top strand. So we're taking the complement, and I also want you to note that this sequence is written 3' GATT 5'. But all the DNA that you'll read printed will be written the reverse of this, with 5' coming first, so 5' TTAG. This is the reverse. So to find this second sequence, to find the second primer, we need to use the reverse complement of what's present in the top strand. One primer has the same sequence as the top strand of DNA. The second primer has the reverse complement sequence to what's present in the top strand of DNA. I hope that this overview gives you a little bit better idea of the idea of reverse complementarity and thinking about primers that align during PCR amplification. All right, bring questions to class, and we'll talk soon.